So one of the first things I'm going to do, I'm going to walk out here amongst you because the presentation today is going to be filled with data. And some of it's pretty dense, so I want to be able to make sure that I can explain to you what's on the graphs that you're going to eventually see here. The first thing I'd like to do is make a point about what we call poultry litter. I find that many grain producers get confused about what poultry litter is. It's used as a generic term, but the truth is that it's used to describe all of the things that you see up here. And here in North Carolina, you have access to manure from poultry farms that we don't have access to. So the vast majority of our poultry litter is actually broiler litter. That's meat chickens, of course, that are produced for consumption. We do not have in our state any layer production or turkey production. But each of these manure types up here and each of these litter types have different characteristics. So when you as a grain producer, you're going to use poultry litter, quote poultry litter, as an alternative fertilizer, you need to make sure that there's differences between all of these. Physical differences, for example. This broiler breeder manure, which we have quite a bit of in our state, tends to not be stackable. The moisture content is higher. And anytime the moisture content is higher on one of these products, generally what that means is that the nutrients are not going to be as dense. So that's something to keep in mind. So this is some maps that I pulled up. I'm obviously I'm very familiar with Tennessee, but not as much with North Carolina. This is soybean production in the state. And the reason I made this map was because I was interested to see where are your different types of poultry farms in relation to where you're producing soybeans. And I guess I didn't realize this was a regional meeting, but here I know you guys have access to turkey barns and broiler production facilities. In other parts of the state where soybeans are produced, there's also access to layer manure, which is a pretty good fertilizer. We don't have access to it, in our state. But there's a lot of overlap, I guess my point is here, between poultry production in the state and soybean production in the state. And really, soybeans is not the first thing that comes to mind when you think about, using an alternative fertilizer, poultry litter. It's usually on corn. So I just want to show you some pictures here. This is a farm I've done a tremendous amount of research on in Tennessee. This is a broiler farm. These are chicks that are on litter. Litter, of course, is recycled on these farms. Not so much as I understand in turkey farms, but this litter is continuously recycled. In this farm in particular, they windrow the litter between flocks. So what you get as a product to use to produce soybeans comes out of a house like this. And it's usually decaked off of the floor, but sometimes they do a full house clean out. So even within this facility here, you're going to have two different types of manure products that are going to come out. One's going to be a cake, and the other's going to be a full house clean out. And if you're purchasing this, you want to make sure that you're aware of that and what the characteristics of it are and what the nutrient content is. The other thing I'll say is that, as I'd mentioned, this producer here, he windrows between flocks. That means that he piles his manure up in a row, he goes through a heating cycle, and then he levels it before his new flocks come in, and that's what these chicks are set on. In the process of doing that, a lot of the nitrogen, the ammonia is volatilized, so what we tend to see in those types of houses is a little bit lower nitrogen concentration in the litter that comes out. This is a broiler breeder farm. There you're going to find that you've got two different types of manure that comes out of these farms. The manure that's underneath the slats, there's no bedding at all there. So what you get out is a pure manure product. And oftentimes in Tennessee, what we see is this is not stackable. It'll want to slump. And so, the moisture content's higher and the nutrient content will not be as dense. And then the other product here, is from the scratch area. And then this is layer manure, something that we don't have access to in Tennessee. And the characteristics of the layer manure vary depending on the production type, whether it's caged or non-caged, and then the type of manure system that they've got. All of this to say that what I want you to do as a grain producer, if you're going to use a poultry litter product, is to make sure that you get an analysis of it so that you know what the nutrient content is. You can't manage it intelligently without knowing what the nutrient content is. And not just the nutrient content, I'd say, but also the moisture content. So make sure that you ask for an analysis. This is some data from South Carolina that just shows the characteristics of all these different types of litter, broiler litter, the cake, and then also the layer manure. And what you're going to see is that it varies, according to the different type of poultry litter. Now here's a little bit of an anecdotal story. So on Friday, I was in the office. I got a phone call from a producer. He had used some poultry litter on a hay farm this past fall. He said, "I'm just not getting any type of response out of it like I normally do with this poultry litter." And I asked him to send me a picture of it, and it's really dark. Would you all agree? It's much darker than it would normally be. What I figured out is that the litter that he had been using had basically smoldered in storage. So the producer got lucky. He didn't burn his litter storage building down, quite honestly. How much nitrogen do you think there is in this? None. Zero. So just the point to drive home here is that you make sure that you get an analysis and you're familiar with what you're using first and foremost. All that said, the research that I'm going to present today, and this is very detailed research, is all on broiler litter. That's the vast majority of the litter that's produced in our state comes from broiler farms. I would suspect that's probably the case here too. Usually it's a 2 to 3% nitrogen, phosphorus, and potassium product, meaning that for every 2,000 pounds, you're going to have 40 to 60 pounds of nitrogen. That's total. 40 to 60 pounds of phosphorus is P2O5, and 40 to 60 pounds of potash. One of the key things to keep in mind is that the nitrogen's not 100% available. I'll show you some data later where we've calculated the availability for a corn crop. And so obviously for soybeans, this is not as relevant, but if you're using it on corn ground, for example, that's something that's really important to keep in mind. When you put down 3 tons, you're not really putting down 180 pounds of nitrogen, okay? You're putting down quite a bit less than that. So that's something to keep in mind. This next point here, I get this question quite a bit. I've got a field with a phosphorus and potassium need based on a soil test. I'm concerned that if I put this litter down at planting, that phosphorus and potassium is not going to be crop available by the time my crop needs it. So we're going to address that today with some of the data that I'm going to show you. I also get questions about availability of sulfur and certain micronutrients in litter. We're going to address that question today with the research also. So I've got 2 different studies I'm going to present to you. One is what I think is a superior approach for soybean producers that have soybeans in a corn and soybean rotation, and that is indirect litter application for soybean in a corn and soy rotation. And the key here is that you're putting the litter down for the corn, and then you're using the residual mineral nutrients from the litter to benefit the soybean crop. So this is a little complex here, but this is how the study is designed. In the first year, we are producing corn. We have a negative control that we just apply phosphorus and potassium based on a soil test. In this case, these soils are medium testing, so they need both phosphorus and potassium. We also use 12 pounds of sulfur, whether we need it or not, quite honestly. And then the positive control also, in addition to that, gets nitrogen. And then we try 4 treatments that are nothing but litter. That's 2 tons, 3 tons, 4 tons, and 7 tons an acre. That's year 1 in corn. And then in year 2 for soybeans, we retest for those plots that are the positive and negative controls. And if they need phosphorus and potassium, we obviously add those again, so no nitrogen on the soybeans. And then we rotate those. So in 2019, for example, we started here, went to soybeans in 2020, went back here in 22, went back here in 23, etc. And I have 2 different plots established in 2019 and 2020 in corn that rotated to soybeans, and we've been doing the test ever since then. And that's at 2 different sites. I'm only going to show you one site because it's a little overwhelming with the amount of data. So let's talk a little bit about the value proposition for litter in a corn and soybean rotation. Obviously, the first thing you want to do is begin with a soil test. You're going to maximize the value of the litter if you have a need for phosphorus and potassium, right? You know you're going to have to use the phosphorus. You're going to have to purchase this product to maximize your agronomic yield. So that's where the value of the litter is going to be maximized, where you have a field that is testing lower, medium, and phosphorus, potassium. It's a lower value for the litter if you don't need one of those two mineral elements. If you don't need phosphorus, then you really can't count the value of the phosphorus in the litter. When you're considering purchasing, that's something that you need to keep in mind. And then the thing about using the litter in a corn rotation is that you can use the litter nitrogen efficiently. The corn sits there, that nitrogen is being released throughout the growing season. That corn grabs that nitrogen and uses it efficiently, right? In soybeans, we can't do that really, because we get free nitrogen, right? So we can supplant the free nitrogen that we get, but we can't really add that to the value. So I think this is maybe a superior approach to fertilizing soybeans is in this rotation. I'll show a little bit of research. This is the research that we're going to go over here today and emphasize this 3-ton rate. And then what I've got down here at the bottom is just an example, and this is not complicated, of how you would consider whether or not you want to use litter as an alternative fertilizer. Call and get a price, and take the total price per ton of that fertilizer divided by the number of units of that element that you have. That gives you your per unit cost. And then use your analysis here. I'm using 60 here. That would contribute to the value of the litter. That's how you do that. Pretty simple. Okay, now the results. We'll take a few minutes to explain what you're looking at. So what you're looking at here is data from Milan. This is in yellow is the corn, and in green is the soybeans. And we started the study in 2019 in corn, and then we went to soybeans in 2020. Then we went back to corn in 21, back to soybeans in 22, back to corn in 23. And then the corn plot that we started in 2020 went to soybeans in 21, corn in 22, and was back into soybeans this year. So every year we have an independent test that involves both corn and soybeans as of 2020. The first thing that stands out, of course, is if you're looking at the corn, what's happening to the yield as my litter application rate is increasing. The corn yields are obviously increasing as the litter application rates are increasing, correct? And that's a pretty consistent finding throughout the study. And what that is emphasizing to you is that the nitrogen in the litter is not 100% available. On high yielding corn ground, you just simply cannot consistently maximize yield using just litter, even with an over-application. And I certainly think 7 tons would be an over-application. So that emphasizes that the importance of the nitrogen management for the litter. For the soybeans, even though in all of these years, we didn't use any mineral fertilizers on any of these results here, we got equivalent yields on the soybean. So what that means is that we're able, even on these medium testing soils, we're able to rely on the mineral fertilizers that are being applied to the corn to carry over to the soybeans. Remember now, litter is only applied when the corn is grown, not when the soybeans are grown. So I think it's really quite a good set of data. No yield difference in the soybeans. The litter nitrogen clearly lowered the availability to maximize your agronomic yield in corn. Now I'm not going to show this here, but we've got another study where we used litter at planting, and then we supplemented that with nitrogen at V6 on corn. An excellent practice, and the yields are all equivalent. So I'm not going to emphasize that today because this is a soybean meeting. But just keep in mind that that's another set of data that I have, and that if you're interested in the data, I'd be happy to talk with you about it and show you the results or send them to you. So this is the leaf nitrogen content. In each year of this study, we collect the corn ear leaves, and we collect the trifoliate leaves, and we measure the nitrogen content in each, okay? And the point is, this is corn, this is soybeans, this is corn, this is soybeans. You're not seeing the bars here for some reason, but obviously this bar goes way up here for the positive control, right? So did that corn have enough nitrogen? where the mineral fertilizer was applied? Clearly it did. These that received only litter did not. This is what is explaining the reduced yield that you're seeing on the corn. There's simply not enough nitrogen being provided to the corn. In the soybeans, the leaf nitrogen concentrations are all the same, regardless of the fact that it didn't get any litter in the year that we grew the soybeans. So the point being is that and I get this question sometimes from soybeans producers, we're not negatively affecting the productivity or the plant characteristics in terms of the nitrogen content in the seed or the leaves by using litter, either in a current year or a prior year. Now we're going to go on to soil nitrate concentration. So that was the leaf concentration. What about the nitrogen in the soil? And it's always very difficult to measure nitrogen in the soil. And I'm sure here in North Carolina with these sandier soils, it is very difficult to do. In Tennessee, sometimes it works and sometimes it doesn't. But this is so we pulled soil cores that were 12 inches at V4 in corn. And you can see what is happening here with the nitrogen concentration in the soil. It's increasing right here, for example, from 2 to 3 to 4 to 7 tons an acre. So the more litter we put on, the more nitrogen we're able to measure in the soil profile. But is it enough to maximize yield? At V4, you can see you've got your planting application of nitrogen here, of the commercial fertilizer. It's there, but generally speaking, and this is just a portion of the data, the concentrations are going to be much higher than for the litter. That's why your corn is yielding lower. There's not enough nitrogen. One of the things that I thought in conducting this study was that, you know, if we can get some of that nitrogen to carry over for the soybeans in the next year, maybe we can give the soybeans a little bit of a jump start with the carryover nitrogen. Maybe that'll improve the yields for soybeans. Obviously, I've already shown you the yield data. It didn't improve yields. And here you can see that, is there any carryover nitrogen here? Not in this year. And in this year, there were differences, but you know, we're talking 20 pounds. It's just not important. It doesn't have a significant impact on the soybeans. So this idea of having carryover nitrogen that might benefit soybeans, we played that idea out and it just didn't work. We don't see it, you know, in the study that we've done in Tennessee. This is from another study just to show you what the nitrogen availability is for this study. And this is basically the yield for the corn with litter and also with commercial fertilizers. And if we plot these out, basically what it shows us is that we had 55% of the total litter nitrogen available. And that's what you see in those soil nitrate numbers in most years. We see about 50% of what we apply come as measurable in the soil on the corn. All right, now I'm going to move on and talk a little bit about the mineral concentrations. Again, this is the leaf phosphorus concentrations. This is for the ear leaf in corn. This is for the trifoliate leaf in soybean. We go back to corn. This is the ear leaf in corn again. And finally here in 2022, the trifoliate leaf concentrations in the soybean. These bars that you see here are sufficiency numbers. Anything below this red line, it's deficient. Anything between the red line and this light green line might be a little hungry, but you probably won't see deficiency. And then this is an excess. And what we see here is that the litter is providing an adequate amount of phosphorus. We never saw any phosphorus deficiencies in the corn or soybeans, but you see that the amount of leaf phosphorus is tending to increase with the litter application rate. That's important because it shows us that the phosphorus that's in the litter is crop available. Would you all agree with that? It has to be crop available, right? So that was a good finding. And then of course, with the soybeans, and then for whatever reason, the graph is messed up here. There's supposed to be a red line here that shows the sufficiency, but it's way down here. So we didn't have any issues with the phosphorus concentration in the soybeans using just litter as a fertilizer and relying on it in a carryover capacity. Remember, we only apply the litter to the corn, not to the soybeans. Now this is potassium, same effect here. It's adequate, even though we're just using litter as a fertilizer. Even at low application rates, we don't really see any deficiency for the potassium. In fact, at the higher rate, we do tend to see higher concentrations of potassium in the trifoliate leaves, which tells me again that potassium in the litter is making its way to the soybean plant, right? It's being used, has to be. And then, so the big question is, I purchased this P&K. I'll probably put out more than what I'm using in my crop. What happens to it? This is really important data. This is the soil phosphorus and potassium concentrations. And what you see is any of the excess mineral nutrients, P and K, that we put out, where is that P and K going? It's accumulating in the soil profile. So each year, we're putting litter on. In 2019, we put it on here. We see an immediate response in the soybeans. We don't put any on the soybeans. It drags the concentration down a little bit going into the next year. We put litter on again here. What do we see happening the next year? The concentration increases again. This is important because, we're using these acid extractions to mimic what we think is plant available. So it's showing you explicitly that the phosphorus and potassium is plant available. Any of this phosphorus potassium that we don't use, we can capture in the soil and we can use it for future crop removal. And that's true for both the phosphorus, which is graphed up here at the top, and the potassium, which is graphed down here at the bottom. And you see the increase here, of course, is a function of the application rate of the litter that we used in the study. I'm not aware of any work that's been done with like this that's similar like this. Just in terms of the rotation and the breadth of the application rate. There's data here that's showing the sulfur concentrations in both the corn, the soybeans, and the soybeans. And what we saw is that basically the take-home message here is that what we see is that the sulfur that's present in the litter is plant available. We see it accumulating here in the corn ear leaves, right? That means that sulfur in that litter has to be crop available because that's the only thing that we're applying to these plots. So if you go back to the value proposition earlier, we're really counting on just the phosphorus and potassium and the nitrogen if you're using it on corn, or the phosphorus and potassium only if you're using it on soybeans. But the truth is, it looks like to me that if you have a sulfur deficiency, that you can also address that with litter. And we've shown that pretty conclusively. Boron, another element. Boron concentrations are low in litter, but we tend to see this result right here frequently. And this is just a portion of the results I've got. But we see this occurring time and time again, that for those litter plots, the soybean leaf boron concentrations tend to be a bit higher in those plots that had received litter, not the year the soybean is produced, but the prior year. So there's another point of value in the litter is in the micronutrients, not just in the macronutrients, the nitrogen, phosphorus, potassium, sulfur, but also in the micronutrients like boron. And if we look at the soil boron and zinc concentrations, we can see this a lot more explicitly, right? Remember, we're measuring these with an acid that's mimicking plant availability for these micronutrients, right? So what are we seeing happening with the boron concentrations over time in soil that's receiving litter in this year and this year and this year? You're seeing those concentrations increase. If we're able to measure it, that means it's plant available. So boron deficiency, again, could be addressed with litter applications, and the same with zinc. So quite a good data set. And there's other elements, by the way, I'm not showing you, manganese and copper, similar results for those also. Now, we're going to move, so that's the first study. I want to pause just for a second. I know it's a lot of information. I want to pause and just give you guys an opportunity to ask me any questions that you may have about that study. Yes, sir?
What do you think is the sweet spot as far as
3 tons an acre. I think that's the sweet spot. And the reason I say that is that, let's say that you're looking for 70, 80, 90 pounds of nitrogen for your corn. If you're using 3 tons of this broiler litter, with what we expect in the analysis. You're going to be able to provide all of the starter nitrogen. Remember, 50% of it's available, about 60 pounds total, 30 pounds available. That's 30, 60, that's 90 units on 3 tons. And then you've got enough phosphorus and potassium, not just to address deficiencies that might be identified with your soil test, but to replace crop removal for both the corn and the soybeans. Probably 2 or 3 years worth. So I think that's the sweet spot. Okay, now we're going to kind of tackle a different animal, a little controversial. I got some folks in Extension that weren't happy that I even did this study. Direct litter applications to soybeans, a little bit controversial, obviously because we don't need the nitrogen. But we did the study anyway, and I think the results are very telling for some value. So obviously, again, the highest, but if you're going to put it directly on soybeans, the highest values, if you have a field that needs both phosphorus and potassium, you can count both of those elements in your figuring here. A lower value, if you don't need one of the elements, you don't need phosphorus, then don't count it. Maybe that's fact. Maybe you should be just using mineral fertilizer. Obviously, the nitrogen has no value. Crop P and K removal, that's another way to look at whether or not and consider whether you'd want to use soybean litter on soybeans directly at planting. That's something that you could consider. Obviously, you don't, in that year, if you don't need P and K and you're putting litter on to replace 2 or 3 years worth of phosphorus and potassium crop removal, you are lowering your profitability in that year that you use the litter. That's the long and short of it. So that's something you're going to have to consider very carefully. Not saying that's something you might not do. Depends on the price, the availability. It's something to consider. But the value is obviously not as high as it would be on soils that need the phosphorus and potassium. The value here is clearly lowered because we're not going to be able to calculate the nitrogen as something that adds value. Organic matter. I want to say something briefly. I'm not even presenting a whole suite of results today on soil health that we did with this study, where we went in, we collected 2-foot soil samples, we looked at soil aggregate stability, organic nitrogen concentrations, organic matter concentrations. I mean, you would think you put 20, 30 tons of litter on a field that you'd be able to see that. We're not able to see any differences in these soil health parameters. And it kind of makes sense if you think about it. There's roughly 2 million pounds in an acre furrow, 6.7 inches. We're adding 30 tons of litter over the course of 2 or 3 years. So I'm not suggesting that the organic matter is not important. I think that it is. And I think that for water holding capacity, we're doing those studies right now. That could be an important point. But for us, we've just not been able to measure, these tangible benefits associated with the organic matter. We're not able to measure them. So the free-fruit stuff is not where your value is. The value is in the mineral nutrients. So for this study, this is the design. We did it 3 years running. We had a negative control that received no commercial mineral fertilizers or litter. We had a mineral control that received phosphorus, potassium, and sulfur. And we set those rates equal to 2 tons of litter an acre. We had a nitrogen plus mineral control. So phosphorus, potassium, sulfur, and then nitrogen equal to a 2-ton litter rate. And then we had these 3 rates of litter that we used. We didn't use any other fertilizers other than the litter on the soybeans. 1 ton an acre, which in my mind is impractically low. That's just kind of stupid. You can't really put out 1 ton of litter an acre is just too low. 2 tons I think is about right. Getting back to your question earlier about what the sweet spot is, I think 2 tons is about right. Direct litter application on soybeans, and when we also did 3 tons. This is an important point. None of these plots had ever received litter. And each year we did this study, we rotated this study to a new area of the field that had never received litter. That's an important caveat for all these results here. This is on ground that has not received litter. One thing that really stands out immediately, and I hear this in feedback from producers, when you grow soybeans and you use litter as a fertilizer at planting, you're probably going to get taller soybean plants. And there's probably going to be, the plants that are there are going to be more robust. There's going to be more plant biomass there on top of the ground when you use litter as a fertilizer at planting. We could probably say it's the nitrogen, but even when we control for the nitrogen, we don't always see that effect. And it's not just us. Mississippi has a study where they looked at R6 soybean biomass. It was 200 to 300 pounds higher if it was fertilized with incorporated litter versus matched chemical fertilizers. An excellent study done here in North Carolina saw the same thing with both the soybean biomass and the biomass nitrogen concentrations, which that's something that we didn't measure. In Tennessee, we definitely seen that, when we fertilize soybeans, especially with the higher rate at 3 tons an acre, we tend to see taller plants. Here's this data. So you'll see that at R1, the plants tend to be higher. This is our litter application rates. These are our controls, and you can see this line is going what? It's going up 3, 4, 5, 6 inches taller plants when we use litter as a fertilizer. And here's the thing. We've seen it both at R1 and R8, and we've seen it every year that we did the study. It's a very consistent finding. So what is that for you all? What does that mean for you? I think one of the take-home message would be when you're looking at your variety trials, you're looking at standability. Maybe you want to focus on soybean varieties that have better standability. And that, I think, would be especially important if you're planting soybeans early in the season. They're going to tend to grow taller anyway, right? So I think that would be a good, practical piece of advice that comes from this data. This is the yield, which is critical. Sometimes we see, when we use litter as a direct fertilizer on soybeans, we see improved yields. We don't see it every year, but in 2020 at Milan in Tennessee, the negative control yield was 71, and the 3-ton rate was 80, and the 2-ton rate was 79. The 80 is statistically higher than the negative control. So this is not just us that finds this occurrence. It's been found as far away as Brazil and Pakistan, and in states like Alabama and Mississippi, here in North Carolina, and also in Tennessee. Occasionally, you're going to get improved yield using litter as a direct fertilizer on soybeans. But here's the key thing. Did we see it this year? You see any numbers, any letters up here? That means all these yield values are the same. That's the same in 21 and 22. And then this is the aggregate value. If I average all of them up, consider all the results through the years, yes, for those 3 years, we were able to bump yield a little bit. And that's exciting, but I want to temper that. Let's think about that for a little bit. So that yield bump through that 3-year average was 4 bushels an acre on the 2-ton rate. We got this sporadic yield cost. We don't understand why this is occurring. I will say that anecdotally it does seem to occur more often in fields that haven't received litter, and we targeted those fields specifically for that reason. But if you look at this and you're assuming, okay, $13 a bushel, I get $50 more an acre, for production. If I compare that with my cost for the litter, and I honestly have no idea what litter goes for in this region of North Carolina, but I would suggest it's somewhere around $50 a ton would be my guess. You can't justify the use of litter on soybeans with just this yield bump that may or may not occur. I think that's the take-home message here. It's too sporadic to rely on. So I don't think that that's something to get overly excited about. If it occurs, great. If it doesn't, that's to be expected. Don't rely on the yield to pay for the soybeans. Rely on your mineral fertilizer need to pay for the soybeans, or for the use of the litter, rather. Nodulation. Let's talk about that for a few minutes. When we put that litter out, obviously we're putting out some plant available nitrogen. Soybeans don't need nitrogen. And this is where my friends that are deeply invested in environmental issues are hammering on me about using litter on soybeans. The assumption could be that nitrogen is subject to loss. to the environment, right? I would argue that that's not the case here. And we saw this in most years that we did the study. This is just for one station and one set of plots here. We see a reduction in nodulation. What that tells us is that the soybean plant is using the litter nitrogen that we put out instead of producing its own nitrogen. So is that nitrogen then subject to loss? I don't think so. And let's say that you need phosphorus. What source of phosphorus are you guys using here?
Most of the time we run commercial product.
Okay, and what form would that be in? DAP?
Yes.
If you put out DAP, what are you also putting out? Nitrogen. We buy DAP because it's cheaper and superphosphate's not available, right? So all this hullabaloo, in Tennessee about the study, I just don't see it. I think litter is a good alternative fertilizer to consider on soybeans because we see that the nitrogen that we do put out, we can't really count that as a value because we're displacing the free nitrogen that we're getting, but I don't think that it's subject to massive losses. And if you need the phosphorus anyway, you're probably putting out nitrogen anyway, right? So that's part of the reason that I did the study, to look at it. So yes, we do see a reduction in nodulation. Doesn't always occur. Here's some data with a huge, a lot of variation, probably because we were adding the nitrogen in this. But the point I want to hammer home here is that I'm not showing you part of the research that we did that's in a master's thesis. The nodulation is not impaired in late season soybeans. So when you run out of that litter nitrogen, the soybean plant is going to take over and it's going to start making its own nitrogen. That process is not impaired even though early season nodulation is reduced. Little mineral availability. Again, this is the common question I get. I put it out at planting. Is it going to be available? The reality is that the phosphorus in these poultry products is water soluble. It should be expected to be 100% available, and all the research that we've done and that Auburn's done and that North Carolina State's done and Arkansas's done shows that the phosphorus should be 100%, basically 100% plant available, even if it's applied as late as planting. And I think that's when the litter should be applied directly to soybeans, because if we don't do that and we put it out 4 weeks before planting, what happens to the nitrogen? It's more subject to being lost, right? So I know that you can't always get litter when you want it, but I think that you should put it out as close to planting as you can. This is a University of Arkansas study. It's a 7-year study, really well designed. Basically what they looked at is they targeted soils that needed P and or K. The very low concentrations, that means yield was suppressed down to 65% of the yield potential. Low soils, 65 to 85% yield potential, and then medium. And then what they did is they took those low testing soils and they used 2 different rates of litter as a fertilizer, and they compared that with mineral fertilizers that were matched. And what they found is that there was a 3 to 9 bushel per acre yield increase on soybeans for both the litter and the matching mineral fertilizers. So what that tells us is that those mineral fertilizers that they put out in the litter was plant available and plant available in time for the soybean to use it. That's what it tells us. Similar trifoliate leaf mineral profiles. And then this is our data here. So these big letters up at the top just show you that there's differences between yield. This is nitrogen, phosphorus, potassium, calcium, magnesium, and sulfur. No differences. Even though we were adding sulfur for the soybean, no differences in the trifoliate leaf macronutrient concentrations. Even though there's year-to-year variations, there's never any difference between what we see for plants grown with just litter, and that's carryover litter, or excuse me, direct litter in this case, versus these controls. The same was true also for the micronutrients, the boron, the copper, the manganese, and the zinc. So I think this, again, bears out that the mineral nutrients in litter are crop available even when they're put out as late as at planting. All right, so now let's go over the take-home messages. First, poultry litter isn't just poultry litter. There's all kinds of different poultry litter. Make sure you ask for an analysis. Be aware that it's, with broiler litter, is going to be the most commonly available is 2 to 3% per ton. That's around 40 to 60 pounds of each mineral nutrient. Remember, the nitrogen is only 50% available if you are putting it on corn. I think the indirect application for soybeans in a corn and soybean rotation is superior because the litter nitrogen is utilized. Right? We know we need that nitrogen. We have to put it out so you get the value of the nitrogen. I think it's a superior approach. The litter applied at corn planting provides the rotational soybeans with mineral nutrients. I showed you the data on the trifoliate leaves. And by the way, I didn't show you any of the seed concentration data. It's the same thing, tells the same story. The unused minerals accumulate in the soil. That's available to replace crop removal in future years. Carryover nitrogen to soybean. I was counting on that. I didn't see that. There's no benefit there for carryover nitrogen. No improvement in soybean yield, but you can potentially reduce costs for the soybean crop and reduce trips over your field. So I think it's an excellent approach to use litter as a soybean fertilizer. Direct application should be considered. I think it should be targeted to soils that need both P and K, or at least one of those nutrients. I would avoid soils that are testing high in phosphorus, that increase environmental losses potentially. You're going to see that your plants are going to be taller and more robust. Don't get overly excited about that because that doesn't translate every year into improved yields. You will see that sporadically. It's not something you can count on. And then I would say that the mineral nutrients, even when you put it on at planting, I think clearly with this body of data that we've got shows that those mineral nutrients are available in time, even for potassium, when we know that the late season demand in soybeans is very high.
Although you saw more robust and taller plants, you have the growing points.
More growing points. So we measured, the only thing that we measured was yield and nodulation. We didn't measure, we measured nodes. We didn't see any difference. Okay, yes. No, okay, so I didn't show that data, but we didn't really see any difference in node counts. And that was even in years when we did see the yield differences, which means that we've got bigger beans.
Of the 50% of nitrogen that becomes available through litter, how do we determine when it's actually available?
When it's actually available? Well, that's the 50 pound per acre question, right? We don't know. The truth is that it varies. It varies with weather, with soil type. So I would say that 50% number is applicable in a growing season. So within 90 days, I would say. I think it's pretty reliable. But not every year it's going to be. I want you to understand this point here. When I tell you it's 50%, some years I've measured it and it's 40%. And some years I've measured it and it's 65%. So, you know, that availability varies from year to year. That 50% is just an average, and that'll depend on weather, you know, primarily, but also soil type. So, but the 50%, that's a pretty good number. Yes, sir?
Have you done any research on putting chicken litter, poultry litter on wheat?
I have. Yep, I have. I didn't present that data, but I do have it. It works well. And I think it's another example of a superior approach, right? Because we can wring all of the value of the nitrogen out for the double crop wheat, soybean scenario, and then we have the mineral carryover to soybeans, right? So yes, I'm sorry, I didn't present that data, but we started that study this past year at our Highland Rim station, and it worked very well. We're studying not just poultry litter there, but also biosolids.
Have you ever done any studies putting the litter in rolling plants, like just doing a stripper and put it right in home jersey versus spread it all out?
Okay, so one thing I need to make clear, and I should have done this earlier, we are a no-till state, and everything is surface applied here. None of it is incorporated, and it's not strip applied. They have done that research in Alabama, however, and it works very well. So this was, I think, in R3. Is that right? I'm an engineer, not a soybean person. So, yeah, it was an earlier season bean, I guess. So the later and earlier you plant the beans, there's going to be maybe some effect with the nitrogen for litter.
Sorry, do you see a difference with that data that you said it's incorporated in? Do you see similar data to what you have in the no-till system versus incorporating it in, or does it?
Much of the research that I've read that comes out of Alabama that has done this type of research has basically mirrored what we see here. I will say that a lot of the research that's been done in Alabama, they've more consistently shown soybean yield improvements than what we've seen in Tennessee. Now, is that because it's incorporated? I would guess so. We can't incorporate, we don't till in West Tennessee. We have less soils there. They're easily erodible. At one time, we had the highest erosion rates in the world. So, you know, it's all no-till for us. No. It's 100%.
Regardless of time, weather.
That's correct. Yep. I mean, I showed you 5 years worth of data there. Yeah, and we see in the trifoliate leaf concentrations and the seed concentrations, if anything, we see increases in the phosphorus and potassium content in the plant biomass and in the seed for phosphorus and potassium. I mean, I'm not sure why we get taller plants. I'm not sure anybody really. I mean, it'd be easiest to say it's the nitrogen, right? And it's that little bump early in the season that makes for a taller plant. But could be. Yeah, right.
You said 90 days, is that the nitrogen available by 90 days after application?
Say again now.
There was a discussion somebody had
Yeah.
about nitrogen. Could become available. Is that just available for around 90 days after application?
I'd say a growing season is what you can count on is about 50%.
How long before it's become?
Okay, so I hear what you're getting at, and I get this question a lot. I'll put it to you this way. I'm not showing you the data from the corn study, but we put 3 tons an acre out on corn at planting, and when we use it just as a starter fertilizer, we don't see any differences in ear leaf concentrations as long as we supplement it at V6 with commercial fertilizer. So I guess my point is that practically speaking, it's there and available even for a crop that's heavily feeding on nitrogen like corn. So, you know, that 80, 90 pounds that we should be getting out of 3 tons, we've seen that very reliably over multiple years at 2 sites. Now, here's the thing, it releases after 90 days also, right? And we have measured cover crops, and we do see in some years improvements in cover crop stands when we use litter as a fertilizer, and that's probably the carryover nitrogen from that season's application. Okay. Okay.